Okay, so finally we got to our sample questions. So we're going to have 3 sample questions that we're going to look at the denominators and see that they do not match. Remember, if you see a minus sign, you know that the first thing you got to do is look at your denominators. The only way you can add or subtract is if these match exactly. This guy doesn't, so we know that we're going to have to go to step 2, find the LCD. Find the LCD, you factor out each of the denominators. Notice 5y, it's a monomial. So the only way I can factor this out is just do 5 times y. Can't do anything else besides that. Now for 18y squared, again, that's also another monomial. Notice no addition or subtraction signs down here. So we're going to do this as a monomial, which means tree diagram. 18 is 2 times 3 times 3. And then y squared, remember that just means that we have 2 of them. 1, 2. Now that I factor out the monomials at the bottom, your denominators, create your LCD list. So let's write down each of the different types. So the first type, remember these are separate. Remember the multiplication symbol separates. So don't think that you have to put 5y down here. Think that you start with 5, that's new, and then the next term is y. If this confuses you with the 5.y and you want to do a comma for right now to show that these are 2 separate items, that's fine. Just remember that when you write it in as a fraction, as a rational expression, do not use the commas. Okay. Over here, 2 is different from single 5 and single y. So if you want to put a comma to separate it. 3 is different from 5, y, and 2. Remember, I'm just writing down each of the different types. 3, already in the list, don't duplicate. Y, already in the list, don't duplicate. Y, already in the list, don't duplicate. We're just writing down the different types. Once you have the different types, then you can do your versus game. We need an amount. Do I need 1 of them? Do I need 2 of them? How many we need? Let's look. For 5s, 1 here, 0 here. Always grab the largest amount. 1. For y's, 1 versus 2, 2 is the largest amount. For 2's, 0 versus 1, we need 1. And for 3's, 0 versus 2, we need 2. So I need 1 5, 2 y's, 1 2, 2 3's. Now that I know what the LCD is, let's raise each of the fractions. So start with the first rational expression. And let's make sure you write it as multiplication now that I have a rational. So 5 times y squared times 2 times 3 squared. Notice I didn't put the 1's here because it's understood. I didn't bother multiplying this out. I know a lot of you are saying, well, why don't you multiply it out? 5 times 2 is 10, and 10 times 3 squared, which is 9, is 90. I want to keep it in this way so I can see what my extra pieces are. So draw your box. And you can see, ooh, you only have 2 passengers, but you have multiple passengers over here. So let's see. 5, 5. Okay, that's good. That's not extra. Y squared. Ooh. 1y versus 2 y's. You must have picked up a y, while you were driving that bus. No 2, but you finally got a 2. So that's an extra piece. Another hitchhiker. And then the 3 squared. That's an extra piece. Now is the time that you probably want to multiply this all out when you multiply it with the 9. So 9 times 9 is 81, times 2 is 162, times y. Okay? So this is the time where I smush them together to multiply with the 9 to get that. Let's do the other fraction. Now instead of me keeping it 18y squared, remember what I told you? Use the factored form. The 2, 3, 3, y, Compare that to 5y squared 2, 3 squared. So you can see what your extra pieces are. The 2, 2, 2 3s, 2 3s, 2 y's, 2 y's. So notice the only extra piece is this 5, because this is here, these are here, these are here, this is the only extra piece. So put the 5 here, and then 11 times 5 is 55. So now that we have the same matching denominators, let me erase the originals so that we're working with the equivalent fractions. Now, because this is all monomial, it looks really sloppy. So this is where I said, okay, now that we're done raising, and they're monomials. If they were binomials, I would leave them as parentheses. But for me, we can multiply this out. That might make it easier for you. 5 times 2 is 10, times 9 is 90, y squared. And notice the top is 162y. And then for the other one, we know this equals 90y squared. And then 55. Now when you look at that, you can see match. We have 90y squared, 90y squared. When they match, we keep that same matching denominator, 90y squared. And then just rewrite the numerators. Put parentheses if that helps you. So you have 162y minus 55. Then you want to distribute to get rid of those parentheses. Okay? Sometimes those parentheses really help you, especially when you have binomials. Looks like it doesn't really change anything because 1 times 162y is 162y. Negative 1 times 55 is negative 55. Now, what you want to do here is see if you can reduce this. Look at the top. It is a binomial. How do you factor out a binomial? Well, either GCF or difference of squares. For GCF, 55, the only things that we can think of is 5 and 11. To be a common number, we definitely know 5 is not in there. So then what you want to do is grab a calculator. See if you can divide it by 11, just to make sure that 162 doesn't have a hidden 11 in there. When you use your calculator and divide by 11, notice you get a decimal point, 14.7, ... So there is no common number, okay? And then we know that they don't have a common ladder. We know they don't have matching parentheses. We know it doesn't start with a negative. So if I can't factor out the top, then nothing can cancel out the bottom because I don't have a binomial 162y minus 55. So this is your final answer.